Okay, so it's a little more difficult to go back from polar back to rectangular, but we're using our same ideas here. We're going to be using the x equals r cosine theta and y equals r sine theta as our conversion factors, basically. And we look here and we see, gosh, I see a cosine theta and I see a sine theta. Neither one of them have r's on them. It would be really helpful if it did. And so, we remember we can do with algebra, we can, so long as what we do to one side we do the other, then we haven't changed our solutions. So we can multiply the entire equation by r, and so therefore the left-hand side becomes r squared. We get negative 3r cosine theta minus r sine theta. And now we can do our conversions, right? We see an r squared. We know that this is going to be x squared plus y squared. We see a negative 3r cosine, so the r cosine becomes x. And we see a negative r sine theta, so the r sine theta becomes y. And hey, we've got this thing converted. It is not worth your time or trouble, and we haven't kind of practiced it to try to solve this for y. It's a pain in the butt. We might want to look at what the plot looks like, though. Let's do that. All right, so I've got this up in GeoGebra. We're going to just put in our equation just like we have it. X squared plus y squared equals negative 3x minus y. And then we can see, hey, it's a circle with a center that is no longer at the origin, but at roughly negative 1.5, negative half. Okay. Now, if we had put this in as polar, we could do that. R equals negative 3 cosine alt t for theta minus sine alt t for theta. Oops. There we go. Okay, so I don't know why. It does some funky stuff there sometimes. Okay, so this should be exactly the same circle, right? If I turn it off, I get the blue circle, no circle, green circle, blue circle, exactly the same. And so we know we've done it right, okay? So you do need to show your work on these things. That's pretty straightforward. Okay, I think we have one more, two more. Okay, so convert polar to rectangular. And we'll start with the easier one first. R equals 9. So this means no matter what the circle, what the angle is, we are at a radius of 9. Right? So this is going to just be a circle. Except I can't draw, but y'all get the idea. It's a really bad circle, but that's a circle. And for this, for converting, we can just say, hey, I know r squared is x squared plus y squared. So we can say r is x squared plus y squared square root. And the only thing here is that this technically really needs to be a plus minus, right? That's what it is. It needs to be a plus minus. Yeah, so that's it. The other one is actually a little bit nicer because we can look at this one and say, well, hey, let's cross multiply, or let's multiply both sides by cosine theta. So I get r cosine theta equals 6. And hey, r cosine theta, that is x. So x equals 6. So either one of those guys is going to work. And so if I turn these two off and I say, hey, r equals 9, oops, we are going to get r equals not 0, 9. And then we got to zoom out. Right? It doesn't want to graph that because there's no thetas in here. So let's say plus 0 times alt t. Okay, I got it to take what I wanted it to here. I put in 9 plus 0 times theta, and it gave me the circle that I wanted to, because basically it needs to have that theta in there so that it knows that it's polar, because otherwise it thinks it's just a variable, that it's a parameter rather. And so there you go. That's it for this one.